Hello and welcome to Engineering Mathematics 4, and the first topic in that is matrices. Up on Microsoft Teams I have put up the booklet with all the questions in it and also an extra set of question sheets which come from Advanced Higher Maths. So feel free to do as many of those questions as you want. The answers to both are up there. Right, so what a matrix is, it's a rectangular or square array of numbers. Now, the difference between rectangular and square is important later on. And these are enclosed normally in curved brackets. You sometimes see them in square brackets, but that would only normally be if you're using a computer program to deal with matrices. And each number in a matrix is known as an entry. So, examples. So, a matrix is always denoted by a capital letter. Okay, so this matrix here has 1, 2 rows and 1, 2, 3 columns. Now, each entry has its own specific name. It's important that we can work out what the entry in each matrix is. Okay, so in this matrix, A11 would be 1 because it's in row 1, column 1. Entry A 2, 3, so that means row 2, column 3 would be the element, so row 2, row 1, row 2, column 1, 2, 3, takes us to here, would be -8. And these should be subscripts, they should look smaller and lower down. If I'm looking at A21, so I should be able to see that A21 is in row 2, 1, 2, column 1. So that means that my element there is just 3. So that's how we can tell the different elements of our matrix. Okay, now a matrix could look like this. And that would just be called a column matrix. Or you could have C like that there. And that would be just made up of a row. So that's a row matrix. So that's how you identify the different elements. That's what a column matrix is. And that's what a row matrix is. Okay. Order of a matrix. Order of the matrix. This is simply the size of the matrix, i.e. how many rows by how many columns. Okay, this is particularly useful know when we are multiplying matrices together. Okay, so the order of a matrix is the size. It's how many rows by, multiply sign just means by how many columns. And as I said, this is particularly useful to know when we are multiplying matrices, and we'll get to that later on. Okay, so let's just do a little question, for example. So let's say that matrix D is 1, -8, 4, 3, 2, 1, 7. Find the order. B. Identify elements. D 1 1, D 2 2, D 1 4, and D 2 3. So let's just look at the answer to this. It's very straightforward. So the order will have got 1, 2 rows along the way and 1, 2, 3, 4 columns. So it's a 2 by 4 matrix. And that's your order. Okay, D11, that just means, and remember, when it's an element, we use the lowercase letter rather than the capital letter. So D11, it's just 1. D22, that means second row, second column, so that's just 1 again. D14 means it's in the first row, but in the fourth column, so that's just 3. And lastly, D23 means in the second column, second row, third column, so that makes it 7. Okay. Okay, so let's look at this next bit, adding and subtracting matrices. Matrices can only be added or subtracted if they have the same order. All that means is that they're the same size. And it's just exactly as you would expect. Move that over a wee bit, it's getting a wee bit blurry on that side. So let's look at this example. So I've got two matrices, A and B. And I'm just going to ask to find A plus B. Take away B. 3A plus B. A plus 2B. Okay, now what I'm also demonstrating here is the fact that you can multiply a matrix by a scalar number as well, like 3 or 2. I didn't see the point in doing a separate note for that because hopefully it is self-explanatory when I do the example. Okay. So I'll just move that so that we can see, hopefully, the matrices. Right, so answer. So A, we're doing A plus B, so that means we've got 1, 4, 7, negative 3, 2, 8, plus negative 2, 8, negative 6, 4, 1, negative 9. Okay, and all you do is you add the corresponding elements, and you will see that in matrices the majority of the mistakes are made just through simple numerical errors. So if you see me doing that, I apologise, but it happens. So 1 plus negative 2 is negative 1. 4 plus 8 is 12. 7 plus negative 6 is 1. Negative 3 plus 4 is 1. 2 plus 1 is 3. And 8 plus negative 9 is negative 1. Simple as that. Okay, let's look at B. So B was the same thing. But instead of adding there, there was a subtract. And remember, if you add a negative number, if you subtract a negative number, it changes to being an add. So 1, so I'll just set up the matrix first. Right, so 1 take away negative 2, so that becomes an answer, that's 3. 4 take away 8, negative 4. 7 take away negative 6 is 13. Negative 3 take away 4 is negative 7. 2 take away 1 is 1. And 8 take away negative 9, that becomes an add, so that's 17. So it's just exactly as you would expect. So let's look at C. So I'll just put the matrices up here for this, right? So in C, it's asking me to do 3A plus B. So what I'm going to do is I'm just going to multiply everything in A by 3 and then add on B later on, because the rules of bid maths still apply. You do multiplying before you would do adding. So if I multiply matrix A by 3, I would get 3, 12, 21, negative 9, 6, 24. B is staying the same because I'm just adding that on. So I just add those on. That becomes 1, 20, 15, negative 5, 7, and 15. Just like that. I'll just leave you guys to finish off D in the notes. Should be fairly self-explanatory and you shouldn't have any issues with it. Right, and I know a lot of this just now, talking about orders, entries, it's all terminology. So if asking a question these things, you need to know the terminology as well as just how to do it, because mathematical terminology is important at times. Right, so the next next part of terminology that's important is the matrix transpose, and we'll be using this a lot later on. So again, this is just an introduction to most of the normal things. Right. Okay, so if we take the transpose of a matrix, we switch the rows and columns around. Okay, and it is denoted normally as A transpose, if it's a transpose on matrix A. You might sometimes see it as being A dashed, but I don't use that terminology at all. So you won't see that in any of my lectures. Okay, so let's have a look at this one. I'm going to do an example. I'm going to give you 3 matrices and we're just going to find the transpose of each. So A is 4, 1, 3, 2, 4, 0. And B is 1, 4, oh sorry, should have a comma in there, that would make it Victor. And a half. And C is X, Y, Z, 0. So matrices at times can contain letters as well as just numbers. It just depends on the matrix we've been given at the time. The majority of the time it'll be it'll be numbers that are contained in a matrix. So, but sometimes if we're doing long simultaneous equations, they'll contain letters as well. But we'll get to that stage. Right, so all it's telling me to do is turn my row into a column. So my row was 4, 1, 3, so I'm going to write that down the way. So my first row becomes my first column, and then my second row becomes my second column. Just like that. B transpose is straightforward enough, it's just one row. So that's just going to become one column. So row becomes column, row becomes column, then row becomes column. So exactly the same we're going to face in C transpose. So that row is going to become that column, so XY, and that row is going to become that column. And if you want, you can label them column 1, row 1, if it helps, but we're going to do that later on when we're multiplying matrices. So just now, I'm just going to avoid using that terminology as much as possible. Right now, again, a couple other things. If the transpose is the same as the original matrix, the matrix is symmetric. And if the transpose is the same as the negative of the original matrix, the matrix is skewed. Symmetric. And I'm just going to put A and B. And notice that we're always using fractions. So these are my examples. That's my matrix A, and that's the start of my matrix B. And as I was just saying there, in matrices I've always used fractions instead of decimals where possible. So if it comes out in your calculator as something being a fraction, use the fraction. So symmetric and skew symmetric matrices don't happen very often, but one of these is symmetric and one of these is skew symmetric. So let's have a quick check. So AT. So this row is going to become this column, so that becomes 1, 3, a quarter. This row is going to become that column, so 3, -2, 0. And this row becomes this column, quarter, 0, 4. Oops. As you can see, they're the same matrix, so those are symmetric. Okay. And then let's do B transpose. So that row becomes that column. That row becomes that column. And that row becomes that column. And as you can see, that all that's happened between the original matrix and the transpose matrix is that the signs have changed. So all of these are the opposite sign. So that's skew symmetric. Okay. Just going to quickly introduce one last piece of terminology, and that's the identity matrix. Right? So identity matrix has ones on the lead diagonal and zeros for every other element. Right, now an identity matrix can only exist if the matrix is square. That means it's got the same number of rows as columns, i.e. 1, 0, 0, 1. It's a square matrix with 1 going down what's known as the lead diagonal. So that's a 2 by 2 identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1 is the 3 by 3. Identity matrix. Okay, so again that's just a bit of terminology, and it is denoted by just the letter capital I for identity. And we're going to come back and we'll use this in the next thing we're going to do. So again, just been introducing transpose matrix, which is AT, which we swap the rows and columns, and identity matrix is just a matrix with 1 on the lead diagonal and zeros everywhere else. Okay. Now this is a key part of matrices, so make sure that you spend some time practicing matrix multiplication. It's going to be the first worksheet I ask you to look at on matrices. Okay. So we can multiply matrices together, provided you have what's known as reverse orders, right? That means when we see the matrix question, the first thing we do is we write the order of the matrix underneath, right? So 1, if the inside numbers are the same, then we can continue, we can multiply them, right? If they're not the same, we say they do not conform. But I'll show you an example of that. 3. The outside numbers tell us the order or the size of so the outside numbers tell us the order or the size of the answer matrix. And I always think when we first come to doing this, write down the size of the answer matrix, because it'll keep us right. As you get used to doing it, feel free to avoid doing that, but I think it's useful to. Okay, then you're going to do row 1 times column 1, right? And that's going to go in the first element here. Then you're going to do row 1 times column 2. Then row 1 multiplied by column 3, etc. Now, between each element that you're multiplying together, you have to add. But I'll show you that by example. So in this one here, we're in row 2, column 1. So in this bit here, we multiply row 2 by column 1. Row 2 by column 2. Row 2 by column 3. So the row that the element's in tells you what row you're multiplying, and the column it's in tells you your column, and so on and so on. Right. So this is my first example. So we've got the matrix A, which is 2, 1, 3, 0, negative 1, 4. And I've got the matrix B, which is 1, negative 1, 3, 2, 1, 0. And it's going to say find or A times B. And remember, AB just means A times B. Right. So, first thing we do is we write the matrices next to each other. Because we're multiplying them. Oops. Like that. Right. Now, you then write the order of the matrices or the size of the matrices underneath to make sure they conform. So that's got 2 rows and 3 columns. So that's a 2 by 3 matrix. Okay? In this matrix here has got 1, 2, 3 rows and 2 columns. So that's a 3 by 2 matrix. So you write the orders underneath. Now, because these 2 numbers are the same, that means that our matrices conform, so they can be multiplied. If those numbers are different, you just simply say does not conform, so there's no solution. Now, the key thing that also tells me is that my answer matrix is going to be a 2 by 2 matrix. Okay, so I know that my next line, set up a big matrix. That's a bit mad, but hey, let's do it anyway. So you're going to have 2 elements in the first. So you're going to have a 2 by 2 matrix. That's one of your elements, that's one of your elements, that's one of your elements, and that's one of your elements. Okay, now, first of all, we're going to write down at the top what row and what column we're in. So we're in row 1, column 1. Row 1, column 2. Row 2, column 1, and row 2, column 2. Now that tells you what you have to multiply together. So in this element here, I need to multiply row 1 by column 1. So all of these here in row 1 have to be multiplied by all of these here in column 1. And between each one is an add. So I'm going to do 2 times 1, which is 2, plus 1 times 3, which is 3, plus 3 times 1, which is 3. Same thing in here, row 1 times column 2. So 2 times negative 1, negative 2, plus 1 times 2 is 2, plus 3 times 0 is 0. Same thing again, but we're doing row 2 times column 1. So 0 times 1 is 0, negative 1 times 3 is negative 3, so just put that in brackets, and 4 times 1 is 4. Then row 2, everything in row 2 times everything in column 2. So 0 times negative 1 is 0, plus negative 1 times 2 is negative 2, plus 4 times 0 is 0. So we just simplify our elements and we should get a nice small matrix. So that was just for working. Right, so 2 plus 3 plus 3 is 8, negative 2 plus 2 plus 0 is 0, 0 plus negative 3 plus 4 is 1, and 0 plus negative 2 plus 0 is negative 2. So that is the matrix multiplication A times B. Okay. I'll just do a second example. And then I'll leave you some questions to try. So let's look at this example. So let's say that matrix X this time is 1, 3, 7, 6, 4, negative 1. And Y is 1, negative 1, 3, 4, negative 2, 0. And obviously I'm just going to find XY. Right. So again, you write the two matrices next to each other. 1, 3, 7, 6, 4, negative 1. 1, negative 1, 3, 4, negative 2, 0. And again, my writing's not the best. The size of my matrices sometimes looks different. Is what it is. Right. So the first thing we do is we write down the order of the matrices. So that's got 1, 2, 3 rows, and it's got 2 columns. This one here has got 1, 2 rows, and 1, 2, 3 columns. So again, those two numbers are the same, so my matrices conform. So then I set up my answer matrix, and again you just get used to doing this. So that means that XY is a 3 by 3 matrix. So you're going to have a lot more elements in here, so I'm going to have 1, 2, 3, that's my answer matrix. Is going to look a lot more like that. And again, if you want, up the top you can label your rows and columns. So row 1, column 1, row 1, column 2, row 1, column 3, row 2, column 1, row 2, column 2, row 2, column 3, row 3, column 1, row 3, column 2, row 3, column 3. And as I'm getting towards the end of the video, I'm pretty much expecting to make a mistake here, because that's what always happens, but let's make sure that doesn't happen. So row 1 times column 1, so that's row 1, that's column 1, so it's 1 times 1, which is 1, plus 3 times 4, which is 12. So this time, because each part's only got 2 elements in it, you're only going to get 2 numbers in your answer matrix for each element. Right, and that's what happens. Right, row 1 times column 2. So that's -1 plus -6. Then row 1 times column 3, so that's 3 plus 0. Okay, row 2 times column 1, so that's 7 plus 24. Then row 2 times column 2, so that's -7 plus -12. And then 21 plus 0. And then lastly, row 3 times column 1, so that's 4 plus -4, -4 plus 2, and 12 plus 0. So I'll just finish off by writing down your answer matrix. So, and please, if I've made a mistake, let me know. I hope I haven't. So that's 13, -7, 3, 31, -19, 21, 0, -2, and 12. And that's the answer to that question there. So that's lecture 1 on matrices. So it was all really about different terminology in it. Now the bit that you have to worry about is transposes, identity, but the thing you have to be getting right is this matrix multiplication. It's by far the most important thing to do with matrices. And it's slightly different to normal multiplication, so you need to get your head round it. The more examples you do, the easier it's going to be for you. Now, in your matrix booklet, which as I said is on Microsoft Teams, it's on Moodle, whatever, if you go to worksheet 3, right, which is on page 24. And I want you to try all the questions. Now, a little thing to note is remember your rules of bid math. Now, if I had a copy of the booklet printed, or I had one with me, I would put it up in front of you now to save you having to go onto Microsoft Word and get it, but unfortunately I don't have one of them copied. That's the issue that we all face. So, if you are struggling to get those questions, take a note or pause the video at the moment. I've got matrix A, B, C and D, and you could try these questions here: AB, AC, BA, CB, CD and AD. So this is a separate set of questions, or there's another matrices question sheet on Microsoft Teams as well. So please, it's really important that you can do matrix multiplication. I will be back with the next lecture on matrices, which will be to do with inverse matrices, more to do with identity matrices, hopefully tomorrow or next week. I know it's a holiday coming up, but let's be honest, we're not doing a great deal, so let's try and get matrices out of the way before the end of April. Cheers.